Welcome everyone to the last day of GS UK virtual conference. This is the CICS track. In this session, Tom and Sam will bring you the topic of simplifying CICS configuration. Over to you, Tom.
Thanks, Jenny. Hi, everyone. Thanks for joining. As Jenny says, I'm Tom, and I've got Sam with me here today. We're developers on the CICS modernization team, and we've come to talk to you today about simplifying CICS configuration through the power of code. And just before we start, just a brief disclaimer to say a lot of what we talk about here is still in open beta. So our things we talk may change as we're in beta. And the future sort of where we're thinking about this going is subject to change at any point. And yeah, just some acknowledgements. So why are we here talking about CICS configuration? Students coming out of uni, fresh onto the scene, don't often come with out-of-the-box skills in a lot of the things that we depend on the mainframe. So we're talking about ZOS skills, ISPF, RACF, VSAM, TSO, JCL. They're not common skills that are taught anymore at university. And we have tried over time to work with universities and get students more involved and educated in those spaces with some success, but it's still quite difficult to find new hires that actually have those skills straight off the bat. And this is quite challenging, of course, when you're trying to hire in these spaces. So what can we do if we can't necessarily educate people in those skills? Well, we can adapt and we can modernize the platform. So there's plenty of skills out there that students do have coming out of universities. So things like Kubernetes, containers, Java, Python, all relatively new things to the mainframe. And we're trying to increase that portfolio relevant things available on here. So how can we modernize the CICS configuration to make it more familiar using these languages and make it easier to work with too? And before we talk about that, let's just have a look at why it's so complicated in the first place. So CICS configuration is a bit like a huge spaghetti mess of entangled things that all tie together to bring you up a system. And you can see here from this slide, we've got all these different bits that are pieced together, your CSD, your sitbombs, your JCL scripts, JVM profiles, and they all come together to get you what is in your CICS configuration, which sits on a combination of Unix system services and datasets. So what makes this so complex is how diverse it is. So there's a bunch of different parts that you have to configure for your CICS region, your JVM profiles, your CSD resources and definitions, your CICS bundles, your JCL scripts, and each of these come with their own semantics and their own understanding to get that piece to work. And there's no sort of common configuration and understanding between each of those. And each requires some sort of like special treatment. So, we've got no in-editor suggestions for any of these, no syntax highlighting. We've got to go and look through the docs on how these work, no validation on these parts. And this here's just some SIP parameters, an example of one of these parts that you have to configure as part of bringing up your CICS region. And now on top of this, if this wasn't complicated enough with all these different parts that we've got to understand in the semantics, most of the time this configuration is shared between multiple regions. So when you're configuring CICS, you're not typically doing one individual system, you're going to be doing multiple systems. So your CSD may be shared between all these systems, your SIP parameters may be shared between all these systems, a JVM profile could be shared between all of these systems. There's all sorts of parts that can be shared across them, and also some unique parts to it too, like the Apple IDs and SysIDs. And yeah, other things as well, like server.xml. So each of this is bespoke, and everyone has their own way of doing this. If you talk to two different customers that are using CICS, they won't have identical ways of configuring and setting up their systems. And now if you look at just like an example here of off-the-shelf configuration, so this here is the instructions for how to set up and enable the debug tool in CICS. And you can see there's a bunch of steps to do this. And everyone that is coming to configure their CICS region is likely to follow these steps and do a similar thing, maybe with a bit of tweaking on top. But in general, what the instructions they follow are going to be the same. So everyone's just wanting here to set their debug tool up. They just, at the end of the day, all they want is they just want the debug tool switched on, but everyone has to go through and we've got to find where the JCL is that we add our DDs into. We've got to figure out where the CSD is to add the data sets for and the lists and the definitions to, and then enable it. And the end goal is the same. It's just debug tool on or debug tool off, but there's so many steps to follow just to get to that same end goal. And this is just one simple example of like many different examples there are in the documentation. So what can we do about this? Our goal is to simplify the configuration of CICS using a declarative configuration language. So when we talk about configuration as code, we're talking about moving the source of truth from files that are in various places all over your system, so those JVM profiles, those JCL files, and moving them to one in situ on-demand place that we can get the config on demand for, and ideally storing that in source control, so somewhere like Git, for example. And the benefit of doing that, well, there's a few benefits. For starters, is using source control means we've got auditability. So now, if we are configuring one in situ file as config as code, any change that goes into there has to be reviewed and approved. So we can see what changes going in. And if, for example, someone were to turn security off in that configuration, you can be like, hang on, no, we're not going to do that. And you can reject those requests. Similarly, if someone were to approve that request and turn security off, you would have the ability to go back and look at what changes were made. So you could see the history of the code in source control and see who made that change and who turned security off. And then we can back that change out very easily because we can see exactly what they changed, which is pretty nice. We also get some other benefits, so things like faster deployment. So any changes can be deployed in the same way with a commit. We can set up pipelines so that when changes go in to our source control, we can, pick those changes up, put them in our pipeline, and rerun and reconfigure the system using that config. So this is an example that a customer showed one recently at a conference, high level of sort of what they were trying to do to get configuration as code to work for them. And so what they did is they took their SIP parameters and they did check them into GitHub. So now all their parameters are checked into GitHub and they have control and auditability and can see who changes what, and that's great. And they then, when changes go into GitHub and are approved, they have Ansible automation. And that Ansible automation takes those changed SIP parameters, regenerates the SIP params and puts them into a data set. And that data set is then pointed out dynamically by their JCL scripts. So they just point at where Ansible is going to build those to, and that gets them a solution, which means that they can now control the SIP parameters on their CICS region. And that's really good. So what's the problem with that? You could all go away today and do this. Absolutely, there'll be no problem with that. But it only gets us so far, because if everyone creates their own config as code solution to this, that doesn't break down the complexity of necessarily working with a CICS configuration. So what can we do to make it fundamentally easier to manage our CICS configuration and make it so that we have this sort of off-the-shelf thing that works for all our customers. And I think the best way to explain it is to show you. So Sam has a demo, and she's just going to take us through this and show it in action.
Yeah, thank you, Tom. Let me share my screen. Hope it is visible. Yeah. So, before going and running the tool, let us first try to understand what is the configuration file looks like. So, as we said, declarative configuration language. Here in our case, we are using a YAML configuration. So, for the people who are not aware of the language or who don't have any previous experience working with YAML, they still can easily read and understand and adapt what's we are trying to do here using this configuration file. So here basically I have connected to my ZOS USS using Zoe VS Code extension, because I feel it is more user friendly to read and fetch the files. So here I have connected to my USS and I have a folder under my user called demos, and this is my configuration file which I'm going to use to create the data sets and configure my region. So for the people who are very much new to Kicks or Z World, who don't know what are the steps we have to follow to configure or to provision a region, they still can use the simple configuration file and create the data sets and then configure a region. So what I'm trying to do here in this configuration file, I have just provided some of the basic details like Apple ID, sys id, region hlq, where I want to create my data sets, and some of the other hlqs and some sit parameters. So by seeing this configuration file we can figure it out. Okay, I am providing some of the basic details, and then for the people who don't know what and all steps we need to follow, what data sets we can create, no need to give any of the values for the data sets. You just use this simple configuration file. With this configuration file we will be able to create the data sets and then configure or provision our region. Now you can ask like how, if we are not going to provide the data set overrides, how can you create the data sets? What are the values which you are using to create the data sets? So the beauty of this tool is if you are not giving any of the overrides, uh, okay, that's fine. We are going to use the default values and create the data sets for you which are required to provision a region. So but you may have your own requirements, do have your own freedom to override the values related to specific data sets. So how can I override the values? For example, now let's see, let's take an example. I want to override dataset name for dataset called aux temp storage, which we need to have while provisioning a region. So I'll just type aux. So here you see, as soon as I'll write couple of letters, it is suggesting me what are the fields we have available here in this configuration file. So as I said, I want to override dataset name for a data set called aux temp storage. So I'll just click on it. So as soon as I click, it is automatically giving all the fields which we have available under this aux temp storage parameter, which I can use to override. So now as said, I just want to if you want to override just the dsn name, you can just provide some value for the dsn name according to your requirements. And if you want to override primary space, secondary space, or unit, you can go ahead and override the values by providing your values here. So something like this you can override for each data set into and you can use this configuration file. Using those override values, we will create the data set and we will help you to provision the region. Now I don't want to override any of these things. Rather, I want to keep this configuration file as simple as that, and I want to create the data sets with the default values, and I want to provision a region. So, what are the default values we are using? I'll first run the tool and then show you how the default values looks for the data sets. So, let me save this file. Now, let's go to the terminal. Yeah, here I have logged into my ZOSS. Here, let's first see this tool has been installed or not. So you can use CICS config. So this CICS config is our CLI tool name which you need to use to run any of the commands. Now I will run one command called -h. So here it should give me some response. So yeah, the tool has given some response where it is mentioning what are the options we have available which we can use to run this tool, like -d, where we have to provide the directory path of the folder where we have our configuration files, and we can use other options like -v, -l to print the logs. Now let's, as I said, I am this configuration file is under this folder called demo1. Let's go to the same folder, cd demos demo1. So just to verify, I have this configuration file here in this folder. Now let's try to run this tool. Xconfig -d. As I'm already in the same directory, I can just give a dot 9, and I want to print the logs of first level, so I'll use -v. And let's run the tool and see what happens. So yeah, if you see here, it is trying to save the state, because next time when you run this tool with using the same folder where you have a configuration file, it tries to it will delete the data sets which it created already, and then it will try to recreate it again using the configuration file, because we want to keep this as a declarative configuration, so that we every time we will refer the configuration file and recreate the datasets as per your needs. So yeah, within a span of second, you can see all the datasets got created. Now these are the dataset which tool created for me. We can verify here using Zoe. So you can use any of the terminal, but as I'm comfortable using Zoe, I'm just trying to search it here. So this is my filter. Let's search. Yeah. So these are the data sets which tool created for me. Now if you observe the dataset names, I had not given any of the dataset name, but it has used the region HLQ as the HLQ, and then default names like DFH oxt, DFH boxt, all these default datasets name it has appended, and it tool has created all these datasets for me. Now here we have two benefits. One is for the people who know how what and all steps we need to follow, they just can come and edit the configuration file as per their need and then provision the region. But for the people who don't know, this tool can be helpful for them to onboard also, because now I was also new for the kicks, and I don't know any of the JCL language, I don't know any of the steps which we need to follow for to provision a region. But after this, when we run this tool and when we see these logs, it's pretty much very self explanatory. Okay, these are the data sets which we need to provision a region. So by this, it's kind of a onboarding process for the new system programmers. They will get familiar with the what and all the configuration which we require to provision a region. So yeah, now let's go and see how the JCL looks like. So this is the startup JCL, and here we have all the job parameters, we have all the DD statements, we have this output DD statements. So here if you observe, I had not given any of the DD statements overriding values, but still tool has created with the default thing. So for output sysout, it has used the default value star, and we do have some couple of the sit parameters. And if you observe some last lines here, these set parameters I had not given in the configuration file, but it added for me by using some of the defaults. So like this, even though you don't know how JCL works, what is the syntax of JCL, you no need to worry. You can just if you just know how to write YAML configuration, you will be able to successfully create the data sets and provision the region. Now let's try to submit this JSL actually and see I am able to log into the region or not. So I'm using jsub command. You can use Zoe also and submit the JCL. Let's submit this. Yes, I got the job ID. Let's check the status first. Yeah, see here, this is a job panel where I can see the jobs. Now the status of job is active, which is good state. Now let's go and log into the region. Log on, Apple ID, IYK 2Z QT3. I guess it takes a little bit of time. It's okay. Some network issue. Hmm. Let me try to reconnect and then see. Log on, Apple ID, IYK 2CQT3. Yes, I'm able to log into the region. So how simple it was. Using just this basic configuration file, I was successfully able to provision my region. Now at last I want to mention three main points. One is, here you can see for the Apple ID, I'm using some syntax like this. So this is called Jinja templating. So here, what we are trying to do is we are trying to use variables in your configuration file to substitute the values. For example, I'm trying to substitute the sysid value into my Apple ID. So that's why I have added this variable, something like this. So this is the syntax to add the variable. You have to add complete path of the variable. Like this is the parent key for the sysid. So kicks region dot sysid inside two flower braces. So like this you can use variables in your configuration file to substitute any of the values. And here also you can see I am trying to add Apple ID here to the region HLQ using the variables. So likewise, wherever you want to add any of the values into your configuration file, you can use the variables. And second thing which I want to mention is about the schema, that it is very much obvious that we cannot remember all of these parameters which we have available in our configuration file. Even though we know there will be a lot of chances that manual errors may happen, manually some mistakes will happen while writing the configurations. So for that, to easy and to enhance the editor experience, we are giving schema with our tool, so that you can apply that schema using VS Code extension called Yama, that is a Red Hat extension, which you can install in your VS Code and then apply the schema which we have given with the tool to your all of configuration file, which will help you to edit the configuration files. Because again and again you cannot go read the documents or refer the samples for simple editing things. So how the schema will help me? For example, I might make some errors while writing some of the parameters. So for example, region JC, here if you see, this is not a valid key. So there only it is showing that compilation error, and it's saying property region I underscore j is not a valid property, it's not allowed. So how to fix it? You can just press control space and it will give what is the right key to use. We can click on it and then our error will get fixed here only. Not only for the keys, you can the schema will validate the values also. For example, let's see aux stem storage only. So here the auto suggestion is happening due to schema only. As soon as I write couple of letters, schema will suggest me what are the keys you have, so you can choose what and all keys you need and just apply it. And then here you see, for the primary space, for example, I will give just 1 2 3. And if you observe here, it is showing the error, and if you just hover the mouse on it, you can see incorrect type expected integer. So likewise the schema will help you to validate the values also. So now by this we will understand, okay, I have to give integer value here. Now if I give the integer value, the error will go. Likewise, you can edit all the configuration files using the schema, so it will give you very nice editing experience. So yeah, this is about the schema. So this is how simple and how easy to use the configuration file and configure our regions or kicks. So yeah, that's it from my end. I'll hand over to Tom again.
Brilliant, thanks, Sam. Share my screen again. So yeah, hopefully that gives you a taste of it. And as Sam just touched on, some of our simplification goals for this tool. A great editing experience, so having those lookups in the schema, docking the schema to explain what the various parameters are and the validation rules that she just showed, and making it suitable for storing in a source code management system. So having it in a unified language in YAML is really nice there too. So we're trying to simplify the configuration as much as possible. And again, as Sam sort of touched on, if all your data sets are going to use the same HLQ, you don't have to provide all those data set names anymore. If you do need to provide some of those data set names, that's fine too. We allow that for you to override any of the data set names you need in the generation. But the idea is that the config tool is not a one-to-one mapping of the JCL that is generated. It simplifies and breaks down what you need. So again, in this screenshot, this example at the top here, we can see that trace is set to rolling true. So what that means is that trace is going to be set on in your region and set to rolling. But now we don't need to specify the sit palms for that. It's just going to figure out what those sit palms should be and set those for us. So in the resultant JCL that would be generated, you'd see, I think it's AUX-TR and AUX-TR SW configured to be on for that, as well as your AUX trace A and B data set. So yeah, that's sort of like touching then on breaking down that complexity and just making it simpler to do these things. On top of that, what we're aiming to do is support extensions in there too, and decompose and entangle some of that as well, so that vendors can provide their own extensions. So for example, we just put examples here of providing a port for your CMCI JVM server, or providing the HLQ to the IBM debug tool to enable and configure on that region. So, bit on the architecture of how this is working. So the CICS config tool itself, as you saw from Sam's demo, is running directly on ZOS. She was logged in on USS. And it's using ZOAU APIs under the covers to run and power the tool. And translating the input configuration that you give in YAML into the correct datasets and USS files to start up the CICS region. And it's doing that using the assets that you provide. So obviously the YAML is an important part of that from SCM, but also we can provide resource definition, YAML files, CICS bundles, JVM profiles, etc. And yeah, it's going to generate that into in situ config on ZOS, and it's going to create you those CICS data sets that you need. It's going to create you the region JCL, CICS bundles, etc. Obviously, this isn't going to work if it's just for CICS. So our aim here is that it's a generic platform for ZOS configuration management. Right now in the open beta, CICS is open, the thing we have available, but it's built on top of a framework to support other configuration management in the future. So the CICS configuration language, yeah, it's an implementation on top of that generic foundation. The desired features, and some of those that you've sort of seen in action already, having built-in validation against the schema and editor support, and variable support too now. But we're sort of looking into the future and thinking about composing that configuration from multiple sources, so multiple YAML files, and extending it with those extensions for vendor support, and providing a library of utility of common configuration management activities, so things to help and support you in building those extensions. And so one of those that we have recently added into the tool that Sam will demo shortly is CICS Resource Builder. So CICS Resource Builder itself is a config as code tool for the CICS that was released recently. And that allows you to manage your resource definitions as YAML documents. And the way that works is you specify two things. The system programmer would specify a model, which is what you see on the right here. So this is a model. And this describes the attributes that the application developer can write and any constraints on those. So you can see at the top here, our prefixes have to have a prefix of MTG, and our transaction prefixes have to have a prefix of M. And then here we say the application developer can define programs and transactions, and these are the attributes that it can define on those. And then on the flip side, the application developer creates that definition file, and here's an example of that definition file here. And you can see in the resource definitions, they define a program. The name has the MTG prefix that is enforced on, and the group has the M prefix on there too, and same goes for the transaction below. And what happens with this is you give Resource Builder your model and definitions file, and it will generate you a CSDUP script. And that's as far as Resource Builder goes with that. So you get the CSDUP script, and then you can submit that CSDUP script using GFH CSDUP to add those resource definitions to your CSD. So we've taken that one step further, and we have integrated the Resource Builder tool into the CICS config tool, so that you can pass it your model and definitions files. And now not only will it generate you the CSDEP scripts, but it will create a CSD for you and add those resource definitions into that CSD for the CICS region at startup. So Sam, over to you. Do you want to show that in action?
Yes, thank you. Let me share my screen again. Yeah, hope it is visible. Yeah, as Tom suggested that here in the configuration file we can provide models and definition file uh, values or details which we will use, and we'll use the resource builder and to install those definitions in our regions. So where to provide those values? So we have this parameter called CSD, under which we have a content. Here you can provide what is the model, what are the model or the definitions which you want to use, and by referring those definitions we will use the resource builder and install the resources in our region. So here the model and definitions, we support both relative path and absolute path. You can give complete path of the model files where your model files are there, and the same for definitions also. You can give a path for the definitions. And here you see this is not just a one value, this is a list. You can provide multiple models or definitions, and we will use all those models and definition and then install all those resources in our region. And here let me show how my model files and definition file looks, which I want to install in my region. So here in the same folder I have a definition file. So basically here I'm trying to install CICS catalog manager application, and for that application these are the definition which I need. So we have some of the files, some of the programs, and couple of transactions. So this is the definition files which I'm going to use. And I do have one model file here. Here I'm basically defining what is the group name I want to have, and what is the list where I want to have this group, so that all the definition will get installed in this group, and this group will be part of a list called cat list. So basically this is a simple definition and a model file which I'm using here in my configuration file. So here you see I have not given complete path, and I have just given the name of the files because these both files are present in the same folder. As I said, it will support the relative path also, so that's the reason I have just given names. So let's see this in action. Let me go to the terminal, and here let's just verify that I have same files, definitions, model, and then region. I have not added many of the details. I'm still keeping the other details same. I just added these 4 lines extra to get the definitions in model file so that I can install the resources in my region. So here let me run the tool kix config -d dot -v. Yeah. So here you see resource builder successfully run with model. So it's giving me what model file and what definition files I'm using, uh, and the resource builder is using those model and definition file to install. So here it created all the data sets, and here if you see each it is adding a group called catman and the list cat list, and it is defining all the definitions here. So within a span of second, the tool created all the data sets, and it did install all the resources in our region. Just to verify that all the definitions have really installed in my region or not, I can show you that. So let's submit the JSL again. Sorry, my bad. Yeah. JSL. Yeah. So let me copy. So to avoid such errors, such mistakes, if you don't want to run the commands manually, you can still come to Zoe and just take the startup JSL and right click and submit. That will also work. So state is active. Now let's go and log on to the region. Log on Apple ID IYK2C3. So yes, I have logged in. Now let's verify that these definitions are really installed in my region or not. So first let's verify this catman group is exist or not. And if it is exist, what are the definitions we have inside it? So let's clear this out. I will run seda expand group catman. Yes, so all these definitions which I had defined here in the definition file have been installed in my region. So you can see all those definitions here. Now actually try to run this transaction and see that application, what I was saying, catalog manager application has been installed in my region or not. So let's go back, clear, run this transaction. Yeah, see here kicks example catalog application. So this application has been installed in my region. I can just enter this list items and see the application working. So it is listing me all the menus details here. So yeah, just by using these 4 lines of the configuration file, we were able to install the definition. So as I said, you can provide list of the models and definitions, not only single value. It's a list. You can provide as many of definitions you want. And not only the model and definition, we support the CSD script also. So by using this key CSD script, you can provide here path of the script, CSD script, and again it's a list. You you can provide multiple CSTUP scripts here, and using those CSTUP script, we will install the resources in our region. Yeah. Mm, this is how the tool works, and it will help us to install all the definitions or resources in our region. Yes, thank you.
Amazing. Thanks. Let me just get my screen back up. Okay, so yeah, so if you are interested in trying out this tool for yourself, it's actually available right now on the CICS TS Open Beta website. So I think there's a link on the next slide actually, but if you just go ahead and Google CICS TS Open Beta, you'll find it pretty easily. If you sign up for that, then you can get access to this tool right now. So in here, we've got the PyWheel that you can install, or the zip you can install through there too, and that schema that Sam showed, as well as a README documentation, which gives you all you need to get started in terms of how to install and set up the tool and how to run the tool for the first time and use it. So prereqs for it, obviously it's running on ZOAU, so you're going to need ZOAU 1.3 installed to use it, as well as Python 3.11. Yeah, here's the link to the Open Beta site. I will upload the slides to this presentation once we're finished. So if you go ahead and get it from there, download the wheel or the zip, transfer it across, unzip it, follow those instructions in the README, and then there's some samples in there too to get you started in the zip file. Here's a list of what's new so far that we've done. We are actually dropping monthly betas on this, so that list will change quickly over time. But this is a list of some of the stuff that's in there so far, and a lot of what Sam's covered today. So the variable support, resource builder support, extra DD support, those kinds of things. That's all we have for you today. Does anyone have any questions? And also, we would love it if you would give us some feedback on the session or on the tool, on anything in that space. There's a QR code there, and that's the session code with a link to give us feedback. Yeah, any questions?
One of the joiner had asked what is the tool name and how to is it required license or not. So yeah, you no need to have license. As Tom said, we have open beta site there. You can go and download the tool and you can try it out.
At the top of the hour and it's lunchtime, maybe that's why there's no questions.
That's great. Sounds great. No further questions from the audience. So thank you all for joining, and I hope to see you in the next couple of CICS sessions. Thank you.